All right. Good morning, everyone. Good morning. Good morning. All right. So I'm starting a series on this channel. Yes. So most universities now are in the second semester. I mean, for 100 level, right? And most of the students are offering this course, Maths 102, and the title of the course is Calculus. All right. So for this series, I'll be talking about Calculus 1. It will be in episodes. So this is the first episode of the series. So calculus 1, that's differential calculus. So calculus is divided into two aspects. You have the differentiation and the integration. So integration will be after differentiation here. So I'm starting with differentiation, that's differential calculus. Right, so for this is episode 1, right? So what we'll be looking at today is just introduction to calculus, introduction to differential calculus, basically. Introduction to differential calculus. Alright, so now, so this is how calculus began. This is how we have the differential calculus. Basically, in mathematics, or let me say coordinate geometry, there's something we call gradients of a point, of a line, actually. Alright, so let's consider this graph. Let's see this is the origin, right? So let's assume I have a line, or let's say I have a point P and point Q. So I can connect these points together, forming a line, right? Alright, so now I want to pick any point on this line. I want to pick any random point on this line. So I will go with this and this. So now, tracing it down to the x-axis. This is the x-axis, right? Don't forget, this is y, this is x, right? So tracing it down to the x-axis, I will call this my x1. Facing these points also, I'll call this my x2. Then I can trace this down, right? So I can also call this my y1 and call this my y2. You can see I formed something here, which is a what? Right angle triangle. You can see the shape, right angle triangle. Right, so the gradient of this line is this. So m is for gradient. M equals to change in y over change in x. That is increase in y divided by increase in x, and that can also be written as y2 minus y1 over x2 minus x1. So this is the formula to get the gradient of a line, basically the increment in y over the increment in x. Alright, so now let's just quickly take an example. Let's say we have point P as a coordinate of, let's say 2, 3, and point Q as a coordinate of 10, 7. So we have to find the gradient of this line. So this is our x1, y1, right? x2, y2, right? So now don't forget that our gradient m is equals to change in y, that's y2 minus y1 over change in x, that's x2 minus x1. So our gradient will be, what's our y2? y2 is 7 minus y1 is 3, divided by x2 is 10, that's 10 minus x1 is 2. So that's it. 7 minus 3, that's 4. 10 minus 2, that's 8, right? Which can also be broken down to 1 over 2, which means that the gradient of this particular line is at 1 over 2. Right, so have you understood that the gradient is change in y over change in x, right? Alright, so now I want to just derive something. I want to derive something quickly, and what I will be deriving is going to help us when we start differentiation properly. Alright, now x2 minus x1 is equals to change in x. Do you agree with me? Yes, because x2 minus x1 is change in x, right? So let's make x2 the subject of the formula. You can have that x2 will be x1 plus change in x, right? Alright, now let's assume we have a function y1. So y1, let's say y1 is a function of f of x1, and just leave it like that. Then y2 is a function of f of x2, right? So now looking at this now, x2 is, let's call this equation, I'd like to call this equation 1, then call this equation 2. So now let's substitute equation 1 into this equation 2. Since our x2 is x1 plus change in x, so we can have that y2 is equals to f of, instead of having x2, we have this f of x1 plus change in x, right? Right, now don't forget the formula for gradient. M equals to y2 minus y1 over what? x2 minus x1. So gradient will now be, what's our y2? Our y2 here is this. Can you see this? This is our y2 here. This is y2. So instead of writing y2, write f of x1 plus change in x. So f of x1 plus change in x, right, minus, what's our y1? Y1 is f of x1. So f of x1 divided by, now also remember from the beginning, x2 minus x1 is what? Is change in x, right? So over change in x. So this formula, taking limits, also taking limits of this formula, we can get the gradient of a line. So let's take limits as, I'll still explain in episode 2. I'll be talking about limit of a function, right? So don't worry, you understand better in episode 2. So taking limit as delta s change tends to 0 of f of x1 plus change in x minus f of x1 over what? Over change in x. So this formula is the formula to get the gradient of a line. Gradient of a line, basically. So this is just a derivation basically. So this formula, when we start differentiation from first principle, we'll be getting this formula again. So let's get ourselves familiar with this particular equation. Gradient is equals to limit as delta s tends to 0 f of x1 plus delta x minus f of x1 over change in x. So yes. Alright, so that's the end of this particular episode 1. So episode 2, I'll be talking about limits of a function and limits to infinity, right? Alright, so just to keep ourselves busy, I'll give us 2 points now. Let's say point A with coordinates, let's say 2, 3, and point B with coordinates 7, 8. So find the gradient. So find the gradient. Tell me your answer in the comment section. Find the gradient m. Don't forget change in y over what? Change in x. So yes, tell me your answer in the comment section. Yes. That's all for this video. Thanks for sticking to the end. Yes, have a wonderful day ahead. Thank you.